Hi, I'm Hayne, and today I'm going to talk about the oxidation of silicon. In simply, the oxidation is means the process which grow the oxide layer on the silicon. Uh, when we make a oxide layer on the silicon, the oxide combined with the silicon molecules and it forms the silicon dioxide. So we can make the silicon dioxide layer with oxidation process, and this layer is used for the dielectrics in semiconductors. But it does not mean that the silicon dioxide, the oxidation process, is only used for to make the dielectric layer in the semiconductor, because as I mentioned before, in the process of mm, process on the etching, if we etch the etch some materials in high aspect ratio with deep RIE, we can see the shape of scallops on the surface when we etch. So we can grow the oxide layer, the silicon dioxide layer on the side, and after finishing the process, we can etch the silicon dioxide layer to smooth the surface to and make the anisotropic etching. Like this, we can use the silicon dioxide layer in various purpose to success to various purpose. Because the oxidation of silicon has some very important characteristic. The first thing is the oxidation of silicon dioxide, which making the silicon dioxide layer has some important characteristic. The first thing is the silicon dioxide is grow with using the silicon molecules on the surface. It means the we can add the oxide in the chamber, or the water which H2O in the chamber in the wet oxidation and O2 in the dry oxidation. The oxide molecules combines with the silicon molecules and it forms the silicon dioxide. In this process, the because the silicon dioxide layer use the silicon molecules on the surface, the silicon dioxide layer grows upside and also it grows to the downside. So the ratio of these two sides is almost, it grows 56% to the upside and 54% to the upside and 46% to the downside. Uh, this characteristic means very important things to us. As I mentioned, when we make a silicon dioxide layer with oxidation, we use the silicon molecules on the surface. So, uh, the number of the silicon molecules cannot change, but the volume of the layer becomes more bigger than ever. So it means the density of the molecules are much more loosened than the original silicon in than original silicon in silicon dioxide layer. So we can say the silicon dioxide has a prosperous structure. Uh, because of this characteristic, the silicon dioxide is very easy to move some materials between us. And now I'm gonna talk about some key points when we do the oxidation. Um, we can grow the silicon dioxide layer with adding some oxide gas or H2O in the oxidation. So at first, when the oxide first contact with the silicon vapor, they can directly contact in the surface. It means the oxidation rate is very dominant on the speed which can unconnect the bonding of the silicon molecules. But so it is linearly increase in this process. And there are few differences in the process with wet oxidation and dry oxidation. But when the time goes more longer, the in the surface there are some silicon dioxide layers. So if we add some oxide or H2O in the chamber to make a to grow a silicon dioxide layer, the oxide have to diffuse on the silicon dioxide layer and contact the silicon molecules. So in the in this time, the oxidation rate is dominant to the speed with diffusion. And second thing, because when we apply the high pressure in the chamber, we can make a same effect with using more lowered temper than not when we are not using the high pressure. Uh, so if we want to make some if we have to use some lower temperature for the other process, we can make the high pressure state to assess the same performance. And the oxidation is dependent to the crystal orientation, because the 111 surface is have more dangling bonds, so it is more easier to react the oxygen. So the oxidation speed is more faster than the other surface. When you make a silicon dioxide surface, it is very important to control the surface roughness, because if the surface, if there are some structures which cannot connected right with silicon dioxide, for example, the ratio of the silicon and dioxide is different with the silicon dioxide, it means they can have the trap, which the carrier can be trapped, energy trap. So it leads to the carrier. It leads to the current degradation, and the S substrate swing become higher. So it is bad for the performance. Today I talked about the oxidation process, and from now we oxidation, and in the next week maybe I'll talk the doping. Thank you for listening, and see you next week. Thank you.